If you've been following along with our Blimp lessons online, you may have done the exercise where you were asked to calculate hydrostatic pressure, the pressure due to being submerged underwater, at depth h, using the equation P subscript hydrostatic equals rho gh. In that equation, g is the acceleration due to gravity, 9.8 meters per second squared, and rho is the density of water, which is 1,000 kilograms per meter cubed, at 4 degrees Celsius. In the exercise, you had to plot the hydrostatic pressure at depths of 5, 10, 20, and 30 meters underwater. Today, I'm going to show you how to calculate hydrostatic pressure using MATLAB. I like to start all my MATLAB scripts by clearing and closing anything that might be open. So, I begin with the statement clear all and close all. Next, I'm going to enter the constants of g and rho. The percent sign in MATLAB lets me enter commons, and I'm using that here to keep track of units on the constants I enter. Then, I am going to create a vector to enter the depths I'm interested in. I use the square brackets to denote this is a vector, and I'm entering the values of 5, 10, 20, and 30 meters. Let's save this file, giving it a name so that we won't lose our work. I'm going to call it hydrostaticpressure.m. Notice I used an underscore between the words hydrostatic and pressure, so that I don't have to have any spaces in the file name. Let's try running the script. Looks good. We can see the outputs for g, rho, and h, and they look the way they should. Now let's calculate hydrostatic pressure, which is equal to rho gh. Again, I'm going to keep track of my units in the commons. I have rho in kilograms per meter cubed, gravity in meters per second squared, and h in meters. This can be simplified down to units of pascals. Let's run this again. This looks to be working, but those values of pressure are large. Let's convert these pressures in pascals to kilopascals. There are 1,000 pascals in a kilopascal, so we'll need to divide our pressure values by 1,000. Now we can plot pressure as versus depth using MATLAB's plot command. And don't forget to label your axes. There you go. That's how we can use MATLAB to help calculate hydrostatic pressure.